going to continue with the questions under mathematical questions. And right underneath the word mathematical questions, you will notice that I am providing for you a table or key of important points that you will need to answer questions, including things like unit changes and so on and so forth. This will always be provided. If it is something that you could look up on a table, I will always provide those things to you, because the key or the important skill that I'm looking for is that you know how to solve the problem. I don't really care if you can memorize random numbers. I need you to know how to apply the problem. That's the skill. So the first question is, I have a 42 feet squared multi-pane glass window. It has an R value of 2.74. It loses less heat than the conventional single pane of 1.54. How much energy is saved with the upgrade in a 4,500 degree day zone? All right, so the first thing I'm going to do is pick out which equation I'm going to use. This question has a degree day zoning. It has R values, so I'm going to pick my Q total question and use that to answer. From there, the units are all the same because it's in R values, which means that it's in Fahrenheit. And yeah, so we can just pretty much plug things into the equation. So let's start writing out the equation. I'm going to zoom in a little so that I can do just that. And for Q total. And I'm going to solve twice. So I'm going to solve once for the more efficient glass window, and then I will solve again for the less efficient. So it's 1 over my Q, or my R value of, I'm going to do the less efficient one of 1.54 to start with. And that's an R value. So R values are feet squared, hours per day, degrees Fahrenheit over a BTU. So that is the unit of an R value. This whole thing is going to be times by the area, which is 42 feet squared, which is all going to be times by 24 hours in a day, which is going to be times by, from my degree day zoning, which is 4,500, and since it's a degree day, it is day per year per degree Fahrenheit. And so I'm going to actually times things up. But before I start timesing, I'm going to clean up my equation. So this is under a 1. Therefore, I can take out feet squared and feet squared. This is under the 1 over here, or, under the 1. So hours and hours can go away from the top. And then over here, in this part of my equation, this is under, because it's 24 hours in one day. So day and day can go away. And then over here, I have Fahrenheit, and over here, Fahrenheit under the 1, so I can take that out. And so my answer will be BTUs per year. That's going to be my answer in the equation, because these are the only units left, just to point out unit questions. And so I'm going to just pause, times everything up, and put down the appropriate answer for part 1. Just keep in mind that you want to do 1 divided by 1.54 to start, and then times that by your area, and times that by your 24, and times that by your degree day. So make sure you're starting with that. And it should be a really big number because it's in BTUs. And remember, a BTU is about the amount of energy that would burn with one really good matchstick. So I get 2,904,454.55 and unit BTUs per year. All right, now the next question, the next part of the question is, what is the difference between the more efficient window? So I'm going to just erase this part of my equation, clean that up, and put in the more efficient 2.74. And I'm going to do the same thing. So I cross out the same units, and I'm just going to do it with this more efficient. And when I set up that whole problem with my more efficient material, I get 1,655,474.45 BTUs per year. If I'm going to ask for the difference, if I wanted to know the difference between the two, I'm going to subtract these two numbers, and I will get my final answer, which is the difference in the amount of BTUs saved. So without further ado, I'm going to raise up my board, and we will start the last question. All right, last question, our example questions is calculate the total heat transfer for 52 hours through a glass greenhouse with an R value of 2.16, the measures of 850 square feet with a heating set at 85 degrees Fahrenheit. The outdoor temperature is 35 hours. And then they want you to finally calculate the heating electrical cost in kilowatt hours. So let's start by solving the first part. So I'm going to solve for this, my change in temperature. And the first thing I'm going to do is just subtract my 85 degrees Fahrenheit from my 35 degrees Fahrenheit and get the change in temperature. Easy math of 50 degrees, so we can just keep going. And I can plug everything into my QC over time, which gives me a nice little setup. So I'm going to solve for time, QC over time, and set this all up. So I can put it in. I have 1 over my R value of 2.16, and this is a BTU, so it is foot squared, hours, degrees Fahrenheit over a BTU. And this is times the area of 850 feet squared times my change in temperature, which is 50 degrees Fahrenheit. Now in this question, I would also have, I'm solving for QC and T would be under, so I can actually put the T on this side of my equation. I can just move it over from my equation box on this side to this side, so I'm going to go over to this side, and since it's division, this is multiplication times 52 hours. And cleaning up my units, this is below the 1, so degrees Fahrenheit crosses out. My feet squared crosses out, and my hours per day cross out. And my answer will be left in just BTUs. And so I can basically times everything up. So I'm going to do 1 divided by 2.16. Then I will times it by my area, my temperature, and my time. And I will get an answer in just BTUs. All right, so I got my answer of 1,023,148.15 BTUs, and I want to change that to kilowatt hours so that I can then figure out how much money I'm spending. So I'm going to use that change in units, my unit equaling over here, and I'm going to divide this number by 3,413 BTUs per 1 kilowatt. Once again, to show what I'm doing, my BTUs crosses out. My answer will be in kilowatt hours, which brings me to 299.78 kilowatt hours. I'm going to round up. And then to figure out how much money I'm spending, I'm going to times this number. I'm going to times this number by my 87 cents per kilowatt hour. Kilowatt hours is going to cross out, and I will get my answer in just plain money amount, right? Because it's in there. So I'm getting 260 and about 80 cents. Well, 81 cents because I'm going to round up. So that's how I would answer these questions. Please watch the video to review, and I do hope this helps. Take care. Bye.